Let's look at the examples for chapter 2, starting with the true and false questions. The sum of the relative frequencies for the relative frequency distribution should be equal to or very close to 1 due to rounding. This is correct. A symmetrical distribution is one in which the right side of the distribution looks like the mirror images of the left side of the distribution. That is also correct. 50 employees at CSG Corporation responded to a survey asking for the number of minutes they commute to work in the morning. 18 employees indicated that their commutes are 15 to less than 20 minutes. The relative frequency for this class is in a frequency distribution would be 0.18. To find the relative frequency, we need to take the frequency of the group that we are interested in. In this case, the group consists of 18 employees, and divided by the total number of employees that we surveyed, which was 50. 18 over 50 is 0.36, not 0.18. Therefore, false. Based on the same problem, 50 employees at CSC Corporation responded to a survey asking for the number of minutes they commute to work in the morning. Management would like to know the proportion of employees whose commute is less than 30 minutes. A cumulative relative frequency distribution using group data would provide the information to answer this question. This is correct, true for this question. Histograms displaying continuous data have gaps between their bars. This is false. The bars are connected when we construct histograms. Bar charts can display data either horizontally or vertically. This is true. Pie charts are an excellent tool for comparing proportions for qualitative data. This is also true. What is a category in a frequency distribution? A class is a category in a frequency distribution. A what displays the proportion, keyword, the proportion of observations of each class relative to the total number of observations. This would be your relative frequency distribution. A what totals the proportion of observations that are less than or equal to the class at which you are looking. This would be your cumulative relative frequency distribution. So this would be B. The following frequency distribution displays the daily sales of muffins at Avalon Bakery. What is the width of each class in the distribution? If we're looking for the width, we will take the difference of any two consecutive lower or upper limits. So you can take any consecutive lower or upper limits, 8 minus 1, 35 minus 28, 21 minus 14, 22 minus 15. They should all give you the same answer. In this case, the class width is 7. The following frequency distribution displays the daily sales of muffins at Avalon Bakery. What is the probability that between 15 and 21 muffins will be sold tomorrow? So the category I'm interested in is between 15 to 21. I'm looking for the probability, the portion of of the frequency, the portion of the total number of muffins that will be sold tomorrow, from 15 to 21. So all we need to do is add them all. If we add them all, they will add up to 50. The frequency for the category that I'm interested in is 13. So to find the relative frequency, we will do 13 over 50. So this will be 20.26. So the correct answer will be A. Now, For the same problem, I want to find the probability that between 22 and 35 muffins will be sold tomorrow. 22 to 35. 22 to 35. So I'm interested in both these two categories. So I will add the corresponding frequencies, 21 plus 3, 24, and I will divide by the total. So the probability will be 0.48. Consider the following frequency distribution. Which rule for constructing a frequency distribution using grouped quantitative data has been violated? So, if we notice here, the classes are not consecutive. So your first class is from 0 to less than 5, and your second class is from 5 to less than 10. So there is an overlap right here. On the third class, the lower limit of the third class is less than the upper limit of the second class. There's another overlap here. So basically, we use mutually exclusive classes. This is the rule that has been violated. Now, let's look at the problems. The following data shows the number of students that came to office hours per day for a particular faculty member. So we have the data given to us. We want to construct a frequency distribution, relative frequency distribution, and a cumulative relative frequency distribution for this data. So we have the number of students, and we want to find the frequency. You will take each of the outcomes and you will count the number of times that you observe it in your data set. If you count all the zeros, you will see that you have 18 zeros. We have 10 ones, we have 6 twos, 4 threes, and 2 fours, for a total of 40. To find the relative frequency, we will need to take each frequency of the category that we're interested in and divide it by the total. So the relative frequency for 0 number of students will be 18 over 40. 0.45. 10 over 40. 0.25. 6 over 40. 0.15. 4 over 40.1, and 2 over 40.05. Then if we add them all, they add up to 1. Cumulative relative frequency, we start from the first relative frequency and we keep adding on the frequencies as we move from class to class, from category to category. So we start with 0.45. 0.45 plus 0.25 is 0.70, 0.70 plus 0.15 is 0.85, 0.95, and the last cumulative relative frequency will be 1. Determine the probability that fewer than 3 students will come to office hours today. Fewer than 3, you're looking for the probability of x to be less than 3. Less than 3 is what? Either 0, 1, 2. So this will be equal to the probability of x to be equal to 2, plus the probability of x to be equal to 1, plus the probability of x to be equal to 0. The probability of x to be equal to 2, we go straight to the relative frequency, is 0.15. The probability of x to be equal to 1 is 0.25, and 0.45 for the probability of x equal to 0. We simply add the corresponding probabilities, and the solution is 0.85. The following data show the number of pairs of men's New Balance sneakers that were sold over the last 25 weeks at a discount shoe store. So this is the data that we have. We want to construct a frequency distribution, a relative frequency distribution, and a cumulative relative frequency distribution for this data. We have, using the rule to figure out the number of classes that we will have, we'll see that if 2 is raised to the power of 5, this is when 32 becomes greater than the sample size. Here you have n equal to 25, so that means that you need to create 5 classes. To find the class width, we will do 24 minus 1, the range over the number of classes. This is 4.6, which we will round up to 5. We start with the minimum entry. The minimum entry is 1. So 1 plus 5 will give us 6, 6 plus 5, 11, 11 plus 5, 16, 16 plus 5, 21. And then to find the upper limits, you will take the lower limit of the second class, you will subtract 1 to get the upper limit of the first class. As soon as you have the upper limit of the first class, you keep adding the class width as you move from class to class. So from 1 to 5, the frequency will be 2. 1 to 5, 1 and 5 included. From 6 to 10, 6 and 10 included, frequency is 5. We have 9 from 11 to 15, from 16 to 26, from 21 to 25, 3. The total is 25. The relative frequency, class frequency over the total number. So this is going to be 2 over 25.08, 5 over 25.2, 0.36, 0.24, 0.12, for a total of 1. Cumulative relative frequency, once again, we start with the first relative frequency and we keep adding on the frequencies, the relative frequencies. 0.28, 0.28 plus 0.36, 0.64, 0.64 plus 0.24 is 0.88, and 0.88 plus 0.12, this will be 1 for the cumulative relative frequency. Determine the probability that 15 or fewer pairs of New Bedford, of New Balance shoes will be sold next week. So, determine the probability that X will be less than or equal to 15. Less than or equal to 15. Basically, you are looking for the cumulative relative frequency of the third class. The third class ends at 15, so you can check straight, directly, the cumulative relative frequency for this class, or you can simply add the corresponding probabilities. So, .08 plus 0.2 plus 0.36, 0.64 for the probability. Now, the following table shows the average number of dinners at a restaurant during each day of the week. This is your frequency. Construct the type of chart that would be most appropriate if the goal was to compare the number of dinners during the week. The best way to kind of visually see a bit more clear your data is constructing a histogram. In this case, we constructed a histogram using the frequency. You can use relative frequency or percent frequency, and your categories are the different days of the week. Straight away, you see that on Saturdays you have the highest concentration of your data. For number 4, a survey of 2,056 adults was asked how many books they typically read in a year. The following table shows the frequency distribution of the respondents. You have the frequency and the responses. Construct a chart that best displays this data. The chart that we should be using is a pie chart, once again, using the corresponding frequencies, relative frequency, I should say, and then you can also use the percent frequency. Now, for problem number 5, The following data represents the high ambient temperature for a particular city over the past 16 days. This is the data that you have. Construct a stem and leaf display for this data. First thing you do is you determine what is your minimum and what is your maximum. Minimum is 52, maximum is 78. So you start from 5, 6, 7, 8. So we have 52, 56, 56, 58, 59, 60, 62, 65, 69, 73, 73, 74, 76, 76, 77, and 78. And this concludes the examples for Chapter 2.